I got an email today from a first-year calculus teacher asking about how to explain to their students an optimization question like: a rectangle is constructed with its base on the diameter of a semicircle with radius 5 centimeters and with two vertices on the semicircle. What is the dimension of the rectangle with maximum area? What are the dimensions with the rectangle? Alright, so a nice idea, a nice tip I have, this is the same question, is to guess and check. And it's an acronym, GUESS. And then it's good to check it. Especially when you're taking an AP calculus exam, you want to check to see if you've answered the question that they asked. Very common thing to do. So part of the G is listing a given. What are they telling us? What is the given information? And in order to list the given, a great idea is to draw a picture. So we have a nice picture here of this semicircle and of the base of this rectangle on that diameter of the semicircle. And then the U stands for what is the unknown. What is it that you are trying to find? The U would be the unknown. So what do we want to find? Find question mark. And for optimization questions, it's going to be you want to find, you want to maximize or minimize something. What is it that you want to maximize or minimize? In this case, we want to maximize the area. And that would be this area right in here. Next up is the E. What is the equation for what we want to maximize or minimize? The equation, and then this equation for the area. I love how that point was labeled x, and this would be x comma y, or x comma being a circle with a radius of 5. Very nice. That's very helpful information. So if we said that this area here is going to be equal to well, let's see, not just x, but 2 times x. It's going to be equal to 2x times the height, which we could just call y, 2x times y. So the next letter is S for substitute. Substitute. We want to substitute it to get it all in terms of one variable, so that we could take the derivative. In other words, to solve. Here in calculus, to solve, we will take the derivative and set it equal to 0. So there's the guess. G-U-E-S-S, guess. And as far as checking, a couple of things that are quite common for checking is to check to see if it's reasonable, to check to make sure units agree, and again to check to make sure you actually answered the question that was being asked. So those are a couple of nice tips that I would share in regards to that. Since we know that this point, that this function, our orange function, is y is equal to the square root of the 25 minus x squared, then we could substitute that in for the y. And there's the substitute. And then we could take the derivative and set it equal to 0. So this was done by the teacher who actually asked the question. So let's see if I can demonstrate or show that. So here was their fine work, that the area of the rectangle would be this and this. And so take the derivative, set it equal to 0, setting the numerator equal to 0, and solving for x, and noting that the length is going to be 2x, and the width would be, or the height would be that. So there's the solution, and there's some tips on explaining it. And now let me take a moment and show you on the Nspire how we might be able to explore this. And so here comes my Nspire file. I'm going to add a graph page, and we want to do a circle. There's a variety of ways that we can put on a circle. So here's a shape, here's a circle, and let's start it at the center. 1, 2, 3, 4, 5 So that's the radius of the circle. We could even show what the equation of the circle is. Isn't that neat? Next off, I want to make a rectangle. But in order to do that, I'm going to go ahead and use this construction tool called perpendicular. So I want to have a perpendicular to this, and then I want to have a perpendicular line. I need it to intersect. So let's actually use a little intersection tool. Points and lines, intersection. Let's get the intersection of this and this. That should work nicely. And back at it with the construction of a perpendicular. Constructing a perpendicular to here. There we go. And I could make this longer, and there we can have a nice rectangle coming right up. Let's go ahead and do the intersection one more time. There it is. And actually, I'll do a polygon with perpendicular, click, click. There's all the points. And we will now do a shape called a polygon. And 1, 2, 3, 4 points. Click it again. And now we have this change of color, filling it in. Well, that orange is nice. There's a nice orange. The driver, this can definitely serve as the driver. Could I drive that one? Nope. Oftentimes, to make the driver something special, we change the attributes to a nice big round circle that's open. And now it's time to hide the construction of this actions hide show. Hiding, hiding, hiding these little lines. And that ought to do it. Last thing that could be done is to find out what the area is. Measurement number 8 on the right click control menu, and there's our nice little 22.4 units squared. The question at hand is, what are the dimensions? Technically, what are the length? So let's get this point. Let's find the coordinate and equation of that point, 3.4, and we already know that the answer quite exactly is going to be, as we were just looking before, what was the solution? 5 square root of 2 over 2. So we could do type in here a 5, the square root of 2, control square root of 2, divided by 2. 25 is that area. And so more could be done, but this is a fun way for students to be able to explore where would the maximum be. It seems a little smaller than 20, up to 20, gets around 25, and then now it's less than that. So solutions can be explored graphically, and that's what I want to say about that. Thanks. Enjoy.